All right, 5-step method. We won't use the 5 steps most of the time. Most of the time, we're only going to use 3 of the steps. Okay? This one will be what I call a 4-stepper. 4 of the 5. Okay? So we might as well talk about all 5 on this one. This is a tough problem when you have to step into the next realm of 5 steps. Alright? It gets really easy when there's no number out in front. Really easy. Okay? But hang with me. I got a new way of teaching this, and I think it's going to work. I saw another pattern this year when I was teaching it, and I like it. So I'm going to go with it. Alright, so the first step is GCF. Okay? What the GCF is what number goes into 2, 1, and 10. What number goes into 2, 1, and 10? Just 1, right? The only number you can think of that goes into the number 2, the number 1, and the number 10 is number 1. Right? So, there's no GCF. So we move to the next one. The next one is parentheses, star, variable. Okay? The star means the number out in front. Okay? Now this is very important. When I put these parentheses here, and I put the star, okay? 2 times 2 is not 2, right? So that means that later on, I've got to do what's called a star cleanup. Okay? And the key to this problem is the star cleanup. The star is 5. Or no, 2, sorry. The star is 2. And I'm going to be pulling out that extra 2 later on. The way I look at this is like when I do linoleum on a floor. Right? When we come in and lay linoleum, we put down some glue. And we trowel it out. Right? We get the glue all even. And we lay down the linoleum. And we start pressing it down. And what do we do after we press out? What happens to the glue? It squeezes out the edges. And then what do? You wipe it down. Right? You clean up the glue. That's all this is. I throw a little extra glue down so that when it sticks evenly, nicely. Okay? So it's a little extra to make a lot less work. Okay? Alright. So that's it. That's your second step. That's not that hard, is it? Just put the numbers in. Boom, boom. Okay? Third step, signs. Okay? Take this sign and put it in. Okay? It's huge. This is huge. Now this sign right here tells me if these 2 signs are the same or if they are different. If it's a sum, they are the same. If it is a difference, they are different. The second sign, in this case, will be different, right? Because it's a minus. So this sign will be different than the first sign. Okay? Different from the first. What's different from plus? Minus. Okay? All right. And that's it right there. Okay? The next one is product and sum. Okay? The product and the sum. It's pi and sigma. Okay? Pi in math stands for the product, to multiply, right? The sum in mathematics is to add, right? But sometimes you add negative numbers, right? So what we do here is we take whatever this is right here. See this? That tells us what we're doing in the sum. If this is subtraction, that means we're subtracting in the sum. Okay? In other words, what multiplies, and this is important, First and last. What's first times last? 20. Okay? What multiplies to be 20, but subtracts to be 1. So what multiplies to be 20, but subtracts to be 1? So there's a lot of different numbers that multiply to be 20, right? Let's talk about a few. There's 20 and 1. There's 2 and 10. There's 4 and 5. Any others? That's pretty much it. Which one of those subtract to be 1? 4 and 5. Right. This subtracts to be 19. This subtracts to be 8. And this subtracts to be 1. So your answer is 4 and 5. So you're going to be putting 5 and 4. It's always big number first. 5 and 4. Okay? And that's factored. Except for one thing. What do we need? I still have a pen. What do we need? To clean it up. Because 2 times 2 is not 2. Right? So I need to take out a factor of 2. So in this case, it's just 2 and 1. But if there was a 12 there, it could be 2. It could be 1 and 12. It could be 2 and 6. It could be 3 and 4. Right? So there's a lot of different variables. Okay? In this case, this is 2 and 1. So does 2 go in these guys? No. Does 2 go into both of these? Yes. So I'm going to take out a 2. I'm going to take out a 1. And I'm dividing it out. So 1 goes into 2 2 times. 1 goes into 5 5 times. That was easy. 2 goes into 2 once. 2 goes into 4 twice. Right? That's it. It's factored. That's factored. So now if I FOIL it, or if I multiply this, if I clamshell this, 2 times 1 is 2. 2 times 2 is negative 4. 5 times this is 5, which would add to be x, which is what my middle number is, right? And 5 times negative 2 is negative 10. And that's what I want, right? So I get back to that number. I get back to the original function. Okay? So, factored. Now that's the hard one, guys. That wasn't too bad, right?
How'd you get the last piece you did?
The 2 and 5?
Like from right down where, so you go down to there and the last problem.
Oh, and I was just explaining how to multiply it?
Yeah.
So what I was doing was I was doing this. 2x plus 5 times x minus 2.
Okay.
And I was going like this. And that would be 2x squared.
Okay.
And this would be minus 4x. And this would be plus 5x. And this would be minus 10. And so that would be 2x squared plus x minus 10, which is what we started with. Right? So it's the same thing as what we did when we factored it out. Does that make sense?
Yeah.
That's the really cool thing, is you always know you're right in math if you check your work. Okay? So let's do an easier one. Alright, let's check this out. First of all, GCF. Does anything go into this, this, and this? Right? Just one. Okay? Alright? Parentheses. There is no star, so it's just x and x, right? Bring down the sign. What does this sign tell me? Are these two signs the same, or are they different? What does a sum tell you? A sum tells you that they are the same. Okay, we'll get there. We'll get there. It's okay. A sum tells you that they are the same. Well, if this second one's the same as this first one, then it has to be a what? A minus. Good job. Yes. Has to be a minus. They're the same. Okay? These two are the same. Okay? This is telling me that this one is the same as that one. That's what it tells me. Okay? Good questions. I love it. Doesn't want to move on until he gets it. I like it. All right. Next. What comes next? Product and sum. Okay? This is why I use colors. Product and sum. You know what's funny is the product in this case is 1 times that, right? So it's just that number. 54. What multiplies to be 54, but it adds to be 15.
Soccer girls, game has been canceled, but there is still practice. Girls, soccer game has been canceled, but there is still practice.
9 times 2.
Good. Thank you. Right? I could have gone through and listed them all, or I could just think about it. 9 times 6. So it's 9 and 6. And guess what? You're done. It's that easy. I swear to God. I swear to God. Okay? This is not hard. This should not be hard to teach. But the way they teach it is they have you do trial and error. You have to learn this and this. And it's really, you have to be a math whiz to get it. They make it complicated. It's not complicated. You don't need to make things complicated. You need to make things simple. Okay? Alright, here we go. I can't solve this if it doesn't equal 0. Okay? It needs to equal 0. If it's not equal to 0, I can't solve it. Okay? So, add 16, add 16. So I get x squared plus 8x plus 16 equals 0. Now I can factor it. Because what times 0? What? If I take 0 and I multiply by a number, what do I get? 0 times a number. 0. Right? A number times 0, what do I get? 0. Right? That's why we get this equal to 0. Because now when I factor it, if I make this 0, it doesn't matter what this is. 0 times a number is 0. If I make this 0, it doesn't matter what this is. Because 0 times a number is 0. Does that make sense? And so that's what we're doing. Okay? So what's our first step? GCF. There is none. Second step. Parentheses. Star variable. Well, there's no star, so it's just a variable. Put the signs in. This sign comes down. This sign tells me that they are same or different. This sign right here, same or different?
Same.
Same. Some means same. Some means same. Different means difference. So this means that they are the same. So that means they both are plus.
So whenever the second one is, usually that's what it is.
No, not necessarily. Whatever the second one is tells you if these are the same.
Okay.
Or tells you if this second one is the same as the first or if it's different from the first.
Okay.
So it can be all bass
So
backwards,
if it's
believe
a
me.
plus, it's usually the same as the first one.
Yeah, if the second one's plus, it's the same as the first one.
Okay. Okay.
Okay? If the second one's minus, it's different from the first. Okay? Just remember that. Same or different, and you'll get along just fine. Alright, next. Product and sum. My product is 16, my sum is 8. We are adding to be 8. What multiplies to be 16 adds to be 8. 4 times 4. Okay? And now we solve. X plus 4 equals 0. I minus 4 and minus 4. I get x equals minus 4. And there it is. Are we done? This is sounds like we're...
No, they let whoever it is let their kids up early.
Oh, okay.
Yeah, we have 1 minute.
We got 1 minute? Should I rush us through it? This is a fun one. You want to see the pattern? Is this a perfect square? What squared is 9? No, 3. 3 times 3 is 9.
Oh, okay.
Right? Okay, so but you know what I'm saying right now? What times what is 4? The same thing. 2 times 2. Now think of this. Is 2 times 2 times 3 12? Is this 2 times this 2? It's a pattern. So is this 2 times this 2? What's that? 2 times 2? 4 times 3? Boom. That means you take this sign. Wait, no, sorry. You take this sign, and that's your answer. Boom. That's factored. Now I just set it equal to 0. And I minus 2, and I minus 2, I get 3x equals negative 2. And then I divide by 3. And I divide by 3, so x is equal to negative 2/3. And there it is. That's a pattern. I'm not expecting you guys to see right away. But it works. All right.